in the previous lesson, we talked about measures of central tendency. All right, this one we're talking about measures of variation. All right, so we're talking about the spread. How far apart is the lowest from the highest number? This is needed when the data is summarized with a single number, such as mean or median. The range is the difference between the greatest value and the lowest value. All right, this is the simplest measure of spread. The interquartile range is the difference between the upper quartile and the lower quartile, and we'll talk about what those are in a minute. And these are more useful measures of the spread because it's less influenced by the extreme values. A box plot. A box plot is, or a box and whisker plot, is the way to display data visually and draw informal conclusions. These only use numbers from the 5-number summary. And the 5-number summary is the lowest value from least to greatest, lowest value, lower quartile, median, upper quartile, and highest value. An outlier is a value that is widely separated from the rest of the group of the data. That is any value that is, but it actually has a value to it. It's any data point that is more than 1.5 times the interquartile range above or below the upper and lower quartile. Okay, so for number 1, it's a simple range problem. If the youngest teacher of the staff is 26 and the range is 41 years, how old is the oldest teacher? So the range would be old versus young, or old minus young. Okay, so if the range is, so the old we don't know, and minus 26 is the youngest staff, equals 41. It's a simple calculation. Add the 26 to both sides, and you find that the oldest teacher is 67. You don't find too many of those anymore. They're more rare than anything. Number 2, I was looking for some shoes and comparing prices. The prices were $45, $65, $70, or $45, $65, $90, and $125 for various retailers. What was the range of the price? So low minus high, you got 125 minus 45, and so they range in prices from about $80. So another way to think about this is like if you use an app like Gas Buddy when you're trying to find where's the cheapest gas around you, and you kind of look at the map or you look at the list, and it said you can kind of gauge, right, where is it actually at the top of it, like the lowest price, the highest price, and the range is like so many cents. Right, so that's one way to do it. But on this one, the prices range $80. All right, consider the following set of test scores. All right, find the IQR. Okay, so we want the lowest point. So 5-number summary. All right, the lowest number is 20. The highest number is 100. These are already in order. Let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers. So the 7th number is going to be my median. 1, 2, 3, 4, 5, 6, 7. So 70 is my median. All right, now I'm going to take the median of the first set and the second set. And so 1, 2, 3, 4, 5, 6. I got 6 terms. So 1, 2, 3. My median is going to be here. 1, 2, 3. My median is going to be right here. And so halfway between 40 and 50 is going to be 45. And halfway between 80 and 90 is going to be 85. So my lower quartile is 45. My higher quartile is 85. The IQR is the upper quartile minus the lower. So this is the upper, this is the lower. And so you got 85 minus 45. So my interquartile range is 40. All right. Now, if you look at the table on the next one, it says find the outliers. And it gives you the high, the low. It gives you all your 5 points. So your interquartile range is simply going to be low minus high. So IQR is going to be 49 minus 15.5. And so that's going to give you 33.5 as your interquartile range. And remember, your outlier is 1.5 times that. So 1.5 times 33.5 is going to give you 50.25. All right, and so if I do my upper quartile plus 50.25, so 49 plus 50.25, that gives you 99.25. So anything above that would be an outlier. And then if I do 15.5 minus 50.25, you already know this is going to be a negative number, which is not on my graph, or not on my set. So this is going to be negative 34.75. So because it's negative, there's no lower outlier. There's no lower outlier, and then anything above 99.25 is going to be an outlier. So the 126 is an outlier. And the 7 down here, it still fits within that range of what's considered an outlier and what's not. So the 7 is okay. So my outlier for this one is simply the 126. Okay, now let's talk about percentiles. So when students take a standard test, such as ACT, SAT score, such as the ACT or the ACT, their scores are often reported in percentiles. Percentile shows a person's score relative to other scores. So we're about to talk about percentiles, then we're going to talk about standard variation and normal curves. Will you teach these in your class? Not necessarily. However, every teacher needs to understand test scores, state test scores, and how they measure up. Are you getting growth? Are you not? Because unfortunately, that's where a lot of that's how a lot of schools determine whether you're a good teacher or not. Are you showing growth in your scores? Growth is important, other than outright test scores. But are you showing growth? Are your scores high? And that's what a lot of schools and admin care about, because that factors into their school rank, their school grade. For better or for worse, that's what it is. Now, I don't necessarily like state tests, but ACT and SAT, I can pitch those tests all day long, because the better you do in those, the more money in your pocket if you choose to go to college. It's just free money, and a lot of it is based on thresholds of certain ACT scores. And depending on how high your sub scores and stuff are, you can collect out of some of these classes that you have to take in college. Now, I'm not saying college is for everybody, but if you're going to college, ACT and SAT are your best bet to get free money. Okay, so talking about percentiles, Ozzy was ranked 25th in a class of 250. What is his percentile rank? So if he's 25th in his class, how many are below him? So 250 minus 25, that's going to give you 225. That means there's 225 below him. All right, so 225 over 250 gives you 0.90, which is 90%, which means Ozzy is in the 90th percentile. All right, in a class of 50, Kat has a percentile rank of 60. Where is her class standing? So in number 6, we're going in the opposite of Ozzy on number 5. Ozzy, we knew where he ranked, and we're trying to find the percentile. Now we have the percentile, we're trying to find class rank. Okay, so we don't know where she's at in the class out of 50, but we know that we got 60th percentile. So when you solve this, you multiply by 50, you get 30. That means there's 30 below. 50 minus 30 equals 20. All right, this means there's 30 below her. So don't just say, oh, I got 30 and say 30th percentile. No, there's 30 below her, so 50 minus 30 is 20. That means that Kat is the 20th in her class. Okay, on number 7, it says the class has grades of 60, 65, 70, 75, 80, 85, 90, 95, 100. Lee scored an 85. What percentile is he in? Okay, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 scores. Lee scored an 85, so 5 people are below him. So 5 out of 9 is 0.556, which is going to be 55.6%. And for a percentile, we would just round that up and say 56%, or 56th percentile. All right. The height in inches of 10 sunflowers in a garden are 24, 28, 30, 32, 33, 35, 36, 38, 40, and 42. If a sunflower is 38 inches tall, what percentile is it in? All right, so once again, we have 1, 2, 3, 4, 5, 6, 7 below 38. There are 10, so 7 out of 10 is 70, which is 70%, which is 70th percentile. All right. The students in a field day ran a race. The times and seconds were 12, 14, 14, 14, 15, 16, 17, 20, 22, and 24. Which time was in the 80th percentile? Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there's 10, so this should be pretty straightforward. The 80th percentile, 22 would be in the 80th percentile because there's 8 below it. So 8 over 10 is 80%. 8 over 10 is 80%. So 22 is the 80th percentile. Okay, in a class of 30 students who had a rank of 4, what percentile is she? So she's 4th in the class, which means 30 minus 4 is 26, which means there's 26 people below her. 26 over 30 is 0.867, which means it's 86.7%, which means she is in the 87th percentile. All right, standard deviation. Variance and standard deviation are two commonly used statements of dispersion. These measures are used based on how far the scores are from the mean. The most sophisticated measure of variation is the standard deviation. Here's your formula. It looks nasty. It's not that bad. I'll show you in a second. And the variance is, or the standard deviation is the square root of the variance. So if you take the square root out of that formula, you get the variance. All right, so for number 11, we're going to find the standard deviation of these numbers. All right, you can put them in order. It doesn't really matter. But here we go. Let's see. So we got 52, we got 50, we got 24, 45, 47, 33, 37. All right, so it's a personal preference where you want to put them in order or not, but it's not a big deal. All right, so we need to find the mean. The mean is going to be add all these numbers up, you get 288, and divide by the number of terms, so 7. That's going to give me 41.14. All right, so I'm going to take each of these numbers on the left and subtract them by 41.14. All right, so on the first one, when you subtract, you get 10.86. On the second one, you get 8.86. On the third one, you get negative 17.14. On 3.8, or on the next one, you get 3.86. The next one, you get 5.86. On the next one, you get negative 8.14. And on the last one, you get negative 4.14. Okay, now, that's the inside, the top part. Now we're going to square this. All right, so that's going to give me 117.94. The next one gives me 78.50. Then we get 293.78. Then we get 14.98 or 14.90. 34.34. The next one. Then we get 66.26. All right, and then negative 4.14 all squared is 17.14. All right, and then we're going to add up this last column and get 622.86. All right, now we're going to use our formulas. The variance is 62.86 divided by 7 because it's the number of students. So n is the number of items. So the variance is the top over 7, and that's going to give me 88.98. And my standard deviation is the square root of that. So the square root of 88.98 is 9.43. Okay, so my standard deviation is this. Now, it seems difficult. First thing you're going to do is take the mean. Second thing you're going to do is you're going to say the value minus the mean. Get your answer. And then the third thing you're going to do is you're going to take your answer and you're going to square it. All right, the fourth thing you're going to do is you're going to take all your squares and you're going to add them up. And then the last thing you're going to do is you're going to use your formulas. Okay, so you add it and you take that number, put it over your number of terms, get an answer, and then take the square root of that answer. All right, so that formula looks nasty, but it's a tedious process, but it's not complicated. Okay, so that's 11. Let's do 12. We'll do the same thing. So on 12, we have the weights of linemen. All right, so we got 195. We have 206, 200. We have 197. We have 300. We have 189. And we have 320. All right. So we're going to take those and we're going to find our mean. So our mean is, if you add all those numbers up, you get 1607. Once again, we have 7 numbers, so we're going to divide by 7. You're not always dividing by 7, but that's what we got this time. That's going to be approximately 229.57. So I'm going to take each of these values and subtract the mean. Okay, so when you get your answers, your first one is negative 34.57. Your second one is 23.57. Third one is negative 29.57. Your third one is negative 32.57. Your fifth one is 70.43. Your next one is negative 40.57. And your last one is 90.43. All right, so we're going to square these answers. Negative 34.57 squared is 1195.08. You square your next answer, you get 555.54. You keep going, you get 874.38. You get the next one is 1060.80. The next one is 449.60.38. 1645.45. 45.92. 8177.58. All right, so that's all your squares. You're going to add them all up. And you get 18,469.68. All right, so I'm going to take that and I'm going to get my variance is 18,469.68 over 7. And that's going to give me an answer of 2638.53. And then to get the standard deviation, I take the square root of that. So 2638.53. And that's going to give me 51.37. Right? So my standard deviation right there is 51.37. Okay? And then my variance, this one asks for the mean, variance, and standard deviation. So you have all three right there. All right, normal curve distribution. The bell curve that shows the data is distributed from the mean. All right, in a normal distribution, 68% of the data is one standard deviation away from the mean. 95% of the data is two standard deviations from the mean, and 99.7% of the data falls to three standard deviations from the mean. And if you look at your edges right here, you got 0.15 and 0.15. And so under the whole thing, you have 100%. Right? Again, you won't necessarily be teaching this in lower grades, but it's good to know as a teacher because of underscores and understand how scores are divvied up and how it ties to funding. All right, so we got our curve set up. It says that 1,500 students, the mean IQ of 1,500 students is 90. So 90 goes in the middle. That's where your mean goes. And then the standard deviation is 10. So I'm going to go up 100, 110, 120. And I'm going to go down by 10, 80, 70, and 60. All right, so if I look at my questions, it says, how many have an IQ between 80 and 10, or 80 and 100? So that's going to be here to here. So that is 68%. Now, we're not done, but I'll come back to that. And then between 70 and 110, that's going to be here and here. That's 95%. And then over 120, so that's up here and forward. So that's going to be that, if you look back up here, that's going to be this number right here, that 0.15%. Now, it says how many have that. So we actually need the number of students. And so what we're going to do is we're going to take, for A, we're going to take X over 1,500 and set that equal to 0.68 because that's the 68%. And then I'm going to multiply. So X equals 1020. So that means there are 1,020 students that fall within the first deviation. For B, I'm going to say X over 1,500 equals 95% or 0.95. So X equals 1425. So that means I got 1425 students that are 95%. 95% of the students fall within two standard deviations, so 1425 students. And then for C, you got 0.15, you got X over 1,500 equals 0.15, 0.15%. So if I'm changing that to decimal, it's going to be 0.0015. I multiply that out, I get X equals 2.25, but I can't have 2.25 students, so I'm going to round down and say that this is 2 students. So I found the percentages very easily, and I did some quick calculations to figure out how many students fit in each bucket. All right. And then on 14, it just says what's the percentages. So this one is a little more straightforward. Okay, so set up our curve. And the first question says, what's the percentage between 58 and 62? All right, so that's this to this. So this can be 68%. Really simple. 68%. All right, and then it says, what is above 56%? So this and forward. Okay, remember that if we go back to our bell curve up here, we're looking at this piece right here. So this is 2.5% if you add up both of these. So times or plus 2.35, it gives you 2.5%. Okay, so we need this and over, and if this is 2.5%, this is everything else. If this is 2.5%, this is 97.5%. All right, so not too bad, 99 or 97.5%. And then the last question says above 64. So we just kind of did this, that this is 2.5%. Like a while ago we had this, and this piece was 2.5%. Now we're asking for this, and this is 2.5%. So 2.5%. Right? All right, so that is your range, your standard deviation, and your percentiles, and your normal curve. So I know that was a lot. If you have any questions, please feel free to reach out, and I'll see you in the next lesson.